I'm going to talk about two completely different things today. First, I'm going to talk about some work that we've been doing, very preliminary work to try to figure out some herbicide options for a new crop, which is perennial flax. And then I'm going to talk about some work I've been doing to develop biodegradable mulches for use in organic vegetable production. And so let's get started on the perennial flax first. I'm working with Dr. Brent Hultke. He's a sunflower breeder at the USDA ARS here in Fargo, North Dakota. We've done a number of years of research looking into developing Linum lewisii, or Lewis flax, as I'll refer to it. So it's a perennial native form of flax. The seed is very similar to annual flax. We've been working for a number of years to develop this crop, and I've been working on weed management options, but we hadn't really explored any of the herbicide options. And so I dipped my toe into it this year and did a little work in the field and also in the greenhouse, mostly to explore crop injury. And where we started was looking at some previous research, the weed control guides for annual flax. I found another paper with some newer chemistries that they were testing in annual flax. And then also Kevin Betts, who worked with Don Wise over at the University of Minnesota with the Forever Green Project, also did a little bit of work with it. And I also consulted with my colleagues. So I got a lot of input, but we had a small number of plots. And first I'm going to focus on the field experiment here. You might think that we do greenhouse first and then field, but that's not how it works. So we started with some field experiments, and we're looking at a couple of pre's, which you can see right here, and then 3 posts. And the flax was planted in December, kind of an unusual time to be planting crops, December the 7th in 2023. And we had great emergence. We were feeling all happy in April. And we got our pre's on, I believe it was April 9th. And then the rain started. And we had standing water in the field and didn't get the posts on until the weeds were way too big. And that was by the end of June. And so we didn't have that great of weed control efficacy because of the problems with the weather. But we were able to assess to some extent the crop injury, although it was, I believe, somewhat entangled with flooding damage. I'm sure with standing water in the fields, you're going to have some anoxic conditions, and those little tiny establishing flax plants really don't like being submerged in water. So all that, those are all caveats when we're looking at the data. And we did look at some control, but here I'm focusing more on the injury. So on your left, you can see what the flax looked like in the field. It's a spindly little plant, not much to it, kind of like annual flax. That's why we really need some good options for integrated weed management in this crop. And then here's a picture of the greenhouse plants, just so you get an eye out. What does this look like? That's what it looks like. Okay, so moving into some of the results, we've got the Cairo product probably caused the greatest injury. On the left, there's a percent crop injury, which consisted of various different symptoms. For the stinger, it was epinasty or twisting, and the Cairo was more sort of bleaching. But you can see that the Cairo definitely had the greatest amount of crop injury, and it also was associated with a reduction in shoot height, which you can see on the right here. So this was measured at 56 days after treatment, so sort of at the end of the growing season. And really only the Cairo treated plants were what I would call stunted. Beyond the stunting that would occur with weed competition. So we weren't able to have hand-weeded subplots in every treatment to disentangle the effect of weed competition from the chemical treatments on the shoot height. But we did have a weed-free treatment, and you can see that all the other treatments were about the same as the weed-free, and only the chiro was, the weedy check. The weedy check had the greatest shoot height, probably because of the competition. They were shooting up, and only the chiro was a little bit less than that. So we basically concluded that most of these would be worth continuing to consider in our research, except for the chiro. We struck that out. So then we moved on to, because it was fall, we needed to keep working on this. I've got a grant that's pending a decision where we're hoping to do some integrated weed research with this crop, and we need these recommendations to do the research. And so we wanted to keep working on it in the greenhouse, and because the stinger seemed relatively successful in the field, we decided to expand more into the group 4 growth regulators and look at them. And we, so here's a list of all those treatments. We looked at the Stinger HL, Cadet, which is not a group 4, MCPA, but it also performed relatively well in the field. We wanted to keep looking at it. And then MCPA ester, 2,4-D. The 2,4-D, there's some notion in very old literature that perennial flax is tolerant of 2,4-D, so we wanted to include that. And then we also looked at curtail, which is a mixture of the clopyrrolid and MCPA. And so those were our treatments. And by the way, these were also mixed with a crop oil concentrate, and they were tank mixed with Accent or nicosulfuron for grass control, because we'd need to add a grass killer to these treatments as well. So getting into the results for this, what we definitely see on the left side is that the 2,4-D treatment experienced the greatest crop injury. And so the other ones seem either intermediate or pretty low amount of injury, Stinger and MCPA on the lower side compared to the control. And then that was 7 days after treatment, so pretty quickly after treatment. Most of the symptoms were just typical growth regular symptoms of twisting or epinasty. And then at 21 days after treatment, the 2,4-D was also stunted compared to the MCPA and the Stinger and Cadet. So we're kind of thinking that the Stinger, MCPA might be good options to continue, maybe the Cadet too, for something different. And we'll be continuing to explore. We're just barely scratching the surface. There's so much more that we could do with this. So we'll be continuing to work with it. And so we got some future studies planned. And I'm also working in conjunctions with other people who are exploring other aspects of this crop, including genetic improvement. So it's a fairly large effort, and what I'm doing is just a small part of it. In the picture on the left, you can see this was the ideal scenario. One little patch that was really great, but this was the hand-weeded check out in the field. And that's what you'd expect a first-year stand to look like. One of the things that's tricky about this crop is it doesn't yield until the second year. And so what we're really interested in, besides controlling weeds in the first year, what are we going to use? Does it hurt the crop in that year? Does it continue to hurt the crop? Or does the crop grow out of any injury and grow well? What is it like to spray second-year plants? What chemistries might they tolerate? So there's a lot of questions. It's a little more complicated maybe than looking into an annual crop. Okay, so I'm going to switch gears here a whole bunch and talk about some composite hydromulches that we've been developing. And here's some information about the partnership, the grant. The people I'm working with are in a number of states. They are in Minnesota, Montana, Washington, and Oregon. And so we're trying to develop alternatives to plastic mulch. It's a especially big problem in organic agriculture because they cannot use the biodegradable film mulches. And the industry is very interested in trying to find alternatives to plastic. I'm sure most of you hear on the news all the time, we're finding out the detrimental effects of microplastics in our environment on human health and other animals' health. And so there's a lot of pressure on these companies to do something else and do something different. So we've been testing these mulches that we're developing in a number of different crops, in strawberry, blueberry, broccoli, and onion. And it's more than just weed control. It's more than just crop impact, yield impact. It's a big project wherein we are assessing soil health outcomes and also looking at some economics. I won't delve into that today. I'm mostly focusing on the weed aspect of it. All right, so, and I'm also going to mostly talk about what happened this year. So we looked at strawberry in 2022, onion in 2023, and then this year we're looking at broccoli, or last year rather. And so we had a couple of different experiments at Abstraca and Fargo, and these mulches consist of shredded newsprint. So that's what this is. And it's mixed with a small amounts of organic glues or tackifiers. So we had 3% camelina meal, 3% gargum, and then 6% of each of those. And then we had a weedy check and a weed-free check. And we apply the mulches first. So here's how the stuff is applied. You throw that shredded paper into this 50-gallon tank and mix it with water in your tackifier. This is a commercial hydro seeder, and the motor is very powerful. So we use the motor from the commercial hydro seeder to mix the material, but it's too forceful for application. For application, we want it to be gentle, so we're not mixing up with soil. And so then we divert the hydromulch from the bottom of that tank into a side smaller pump that we use to apply that material. And this is what it looked like on campus. These are some of the plots. After the broccoli has grown quite a bit, I would say this was several weeks after application, and you can see that the hydromulches are doing a pretty good job of suppressing the weeds compared to the bare soil. And then we'll look at those results where we've got comparisons of our polyethylene film. So this is the industry standard. And then we have our weedy check, and we have our various different hydromulch treatments with either 6% or 3% of those materials. And it's pretty easy to see the trend here. The polyethylene had 0 weeds. It's definitely the best at suppressing the weeds. However, the hydromulches perform pretty well, especially the 6% formulations have a very low density of weeds. This on the left, this is earlier, a little bit earlier, and this is right before harvest. Same pattern that you see. And then also looking at weed biomass quantified at harvest, you can see the same pattern. The weedy check has a ton of biomass. The polyethylene is 0, and all of our hydromulches are fairly low weed biomass. However, once you switch over to looking at yield, there's a different pattern. Here we see that the greatest yield was achieved by the polyethylene treatment, obviously with fewer weeds, but then also the weed-free check. And then all of the hydromulches were equal to the weedy check, even though they had substantially less weeds than the weedy check. And I really think there's something else going on besides weeds here, which I'm going to talk about. And so what explains this yield loss? We had a lot of water in the field, and if you can hone in on the poly mulch line, which is kind of this olive green line, you can see that this graph is mean soil moisture content, and that polyethylene has the lowest moisture, which in this case was good because this scale is a proportion. So this is 45 to 40% water in that soil type. It's going to be near to saturating, probably anoxic conditions. And then later on the season, right before the harvest, you can see that polyethylene treatment, as well as the weed-free check and the poly mulch, all had more friendly water contents. And then another issue is, as I mentioned, we will apply this before the crop is planted, and we're thinking we really need to apply it after the crop is planted. I'm kind of speeding through this a little bit. I'm out of time, but we did work with a farmer who came up with a system for doing this. I think it would be better to work on that for crops that are planted as seedlings. And then finally, here's some future directions. We're wrapping up this project, but there is some interest in industry, and I might develop future projects looking at this. We still have a lot of formulation and application issues to solve. And don't think I have time for questions, but if you're interested in the hydromulch, you can scan this QR code, and there's a longer video that talks about it in more detail. So thanks a lot.